Hello everyone, myself Hans. Today we are going to solve the given problem from topic ordinary differential equation. Question is given, solve 2d cube minus of 7d square plus of 7d minus of 2 bracket close y is equal to e to the power of minus 8x where d represent d upon dx. Let's solve the problem. Given differential equation is this is given by 2d cube minus of 7d square plus of 7d minus of 2 into y is equal to e to the power of minus 8x. Here this is the form of f of d y is equal to qx, and from here we have to find this is qx is equal to e to the power of minus of 8x, and further we have to find further we have to calculate auxiliary equation of the differential equation. We can also write this is 2d cube minus of 7d square plus of 7d minus of 2 is equal to 0. We have to find the auxiliary equation to calculate the roots of the given equation. We can also take 2d cube and minus of 2 in one bracket. This is written as taking 2 common. 2, this is d cube minus of 1, and here we have to taking minus of 7d square and plus of 7d. We have to take minus of 7d is taking common. This gives d minus of 1, and this is equal to 0. And further we can also expand d cube minus of 1. This is the form of 1. We have to also 1 cube is 1, so we have to expand a cube minus of, this is a cube minus of b cube. This is written as a minus of b, and another bracket a square plus of ab plus of b square. Similarly we have to expand here d cube minus of 1. We can also write here 1 ka cube is 1, so nothing to affect, so we have to expanding here. This gives 2. First we have to write here d minus of 1, and another bracket we have to writing this is d square plus of d and plus of 1, and here is minus of 7d into d minus of 1 is equal to 0, and from here we have to take a common d minus 1, taking common. This is given by d minus of 1 is taking common. This gives here 2 times of d square plus of d and plus of 1, and here is minus of 7d is equal to 0. Further we have to solve. We can also write this is d minus of 1, and in the bracket we have to solve in on multiplication with this is 2d square plus of 2d and plus of 2, and here is minus of 7d is already present is equal to 0, and further this is written as d minus of 1, and another bracket is 2d square and 2d minus of 7d. We have to write here 5d minus of 5d, and here is plus of 2 is equal to 0. And further we can also factorize the second bracket. We can also write this is d minus of 1, and another bracket we can write here 2d square and minus of, once again, minus of 4d and minus of d plus of 2, we have to factorizing the terms, we get on adding we get minus of 5d, on multiplication we get once again minus plus of 2. Here is a square minus of ab, minus minus on multiplication we get plus, and further we can also factorize. This is written as d minus of 1, and we can take from here, taking 2d is common, and this is d minus of 2, and another bracket we have, from here we can take minus 1 is common, this is d minus of 2 is equal to 0, and from here this is written as d minus of 1, and from here we have to take in, first we have to take in, this is d minus of 2, d minus of 2, and here 2d minus of 1, 2d minus of 1, this is equal to 0, and we have to find the roots of this equation, taking d minus 1 is equal to 0, and we can also take d minus of 2 is equal to 0, and similarly we can take 2d minus of 1 is equal to 0. We get the three roots. From here we have to get d is equal to 1, and from here we get d is equal to 2, and from here we get d is equal to 1 upon 2. From this we have to write the complementary function of the given differential equation. So we have to write here complementary function of the given differential equation. Complementary function of the given differential equation is written as c1. Using the first root we have to written as e to the power of x, and similarly we have to using the second roots, this is first roots, this is second, this is third, so we have to writing c2 e to the power of 2x, and further we can also write c3 e to the power of, here this third root is 1 by 2, so we have to write here x by 2. This is the complementary function of the given problem, and further we have to find particular integral of the given problem. And particular integral is given by, we have to figure out the complementary function here, and we have to find the particular integral, and particular integral is given by 1 upon of f of dy into qx. Putting here 1 upon f of dy is given by, we have to calculating earlier, this is d minus of 1 and d minus of 2, and this is d minus of 1 by 2, and here is qx is given by e to the power of minus 8x, and we have to putting here in place of d, we have to putting, here is comparing with e to the power of minus of ax, so we get a is equal to minus x minus 8, so we have to put d is equal to minus of 8. Putting here we get 1 upon of minus of 8 minus of 1 into minus of 8 into minus of 2, and here is minus of 8 in minus of 1 by 2, and e to the power of minus of 8x. And similarly we have to solve, we get the particular integral. This is particular integral is equal to, here minus 8 minus 1, this is minus of 9, and this is minus of 8 and minus of 2, this is minus of 10, and here we have to solve, this is given by 8 to the 16, and minus of 16 minus, this is minus of 17 upon 2, and from here e to the power of minus of 8x. We can again, we have to calculating 8 to the 16 minus of 16 and minus of 1, minus of 70 upon 2, and from here we have to cancel out 2 5 the 10, and we have to multiplying here. This is on multiplication. This is particular integral is given by minus of 9 into minus of 5, we get 1 upon minus of 45. Once again we have to multiplying, otherwise we have to multiply 17, 5 are 85, this is plus of 85, and again we have to multiplying with minus, we get 9 5 are 45 and 9 8 are 72, 72 plus 4 is 76. We get from here, this is 765 e to the power of minus of 8x. Once again, we have to missing the, when we have to calculating particular integral. Once again, when we have to take a factor, from here we can also have a 2. When we have to taking from here, this is 2dq minus of 2, we have to rough here, 2 is taken into outside, this is dq minus of 1, dq minus of 1, dq minus of 1, once again dq minus of 1, and here is minus of 7d is taking common, this is d minus of 1. We can also put this, and 2 is taken out once again. 765 multiplying with 2, this is 5 to the 10, 2 6 are 12, 13, 7 to the, this is 1530. We can miss out the terms 2. So we have to multiply it here with 1 by 2. We get the particular integral. This is 1 upon 1530 e to the power of minus of 8x. And we have to write the general solution. General solution is given by complementary function plus a particular integral. Here general solution is, complementary function is here c1 e to the power of x plus c2 e to the power of 2x and plus of c3 e to the power of x by 2, and the particular integral we have to calculating here 1 upon of 1530 into e to the power of minus 8x. This is the required solution of the given differential equation. Thank you class, and thank you for watching.